Hey there, Mr. Wilford here. Just wanted to go through Chapter 7, Section 4, and we are applying properties of similar triangles here in this section. Of course, we've been talking about, proportions and similarity between polynomials in the last section. We kind of narrowed it down to similarity between triangles and a couple of theorems there. We want to continue that thought and take a look at some application problems here a little bit. First of all, well, look at this painting. One of the things that you notice here is that we have similar rectangles inside here, and what that does is it provides a little bit of depth to that picture. So there's a lot of math and geometry, of course, everywhere. So let's take a look first of all at this triangle proportionality theorem, Theorem 741. And this theorem says if a line to a side of a triangle intersects the other two sides, then it divides those sides proportionally. And so let's take a look here at what's going on. So we're talking about a triangle, and we're looking at this line intersecting two sides of the triangle, and it's parallel to this side. So EF and BC are parallel to each other. What happens is we get this kind of proportion, this kind of ratio that we can set up. If you look at these, we're looking at side AE, comparing that to EB, and that's going to equal AF compared to FC. So it really cuts these two sides. The line that it goes through those two sides cuts these two sides by a proportion. And one of the things that we can look at here is a construction. If you look at the construction, we can use a straight edge to draw a triangle ABC. We can label E on this side AB, and then we want these two parallel, BC and EF, to be parallel, so we can construct that so that these will have the same angles. And that would give us that a look at that theorem. Okay, so we have here an example then finding the length of a segment. And again, you can see by the drawing here, the drawing that we have X, Y, and CB being parallel to each other. And so we're just using this idea of the triangle proportionality theorem, where we set up 9 divided by 4, 10 divided by y. This really is the side that we're trying to find. And then we just use our cross product, and we can solve for y. Then, of course, we have the converse of that triangle proportionality theorem. If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So now we're saying, basically, we're given the fact that we have this kind of proportion with these two sides. Then we can say EF is parallel to BC. And again, you can take a look at an example here showing that. Then we have a corollary that follows, two transversal proportionality corollary. It says if 3 or more parallel lines intersect two transversals, then they divide up the transversals proportionally. So this is just kind of an extension from that theorem that we started with. So now we have these 3 lines that are parallel, and we have these 2 transversals. Basically what we're saying here is that we have this proportion AC divided by CE is proportional to BD divided by DF. Kind of follows along the same lines. Here we have an application problem. You can read through that. And then finally we have a triangle angle bisector theorem. And basically, again, this is a proportion. If we bisect this angle A, we can say that BD and DC will be proportional to AB and AC, so the sides of the triangle. Take a look at that stuff there, and if you have any questions, please let me know. Thanks.